All right, guys. So we're going to go on and get started with the chapter here. So chapter 3 that we are starting today is somewhat of a continuation on the previous chapter in that we're still talking about quadratic functions and quadratic equations. Now, for the most part, our quadratic equations for this chapter here are going to be in standard form. And when we say standard form, I'm referring to our ax squared plus c. And it'll either be as y equals or f of x equals this here. The only other way we would write it is that y would be 0, and in those cases we would be solving. We'd be solving the equation. And one of the first things we're going to look at is factoring, but when we look at this here, it's really multiplying them back out. So we're not going to look at both of them, we'll look at the first one here. Because when we talked about distributing, simplifying these out, we would multiply through first. We would do our 4x times x, which is 4x squared. Our 4x times negative 3, we'd have negative. 4 times 3 is 12, and we still have our x. Then we do the same thing with our negative 5. Negative 5 times x is negative 5x. And negative 5 times negative 3 would be plus 15. We multiply through. And then the last thing we need to do is combine like terms. Our only two like terms are negative 12x and negative 5x, telling us that we have negative 4x squared minus 17x plus 15. Or 4x squared, it should be positive, yes. 4x squared minus 17x plus 15. So when we multiply these together, we get these three terms. Now our 4x squared came from the product of 4x and x. 15 came from the product of our 5 and 3. So if we're going to factor it, we're going to go the other way. We're going to start with 4x squared minus 17x plus 15 and factor back to this here. Now there's many different ways to do this. And we'll get the second one here, this here. I have a feeling we're going to be a little pushed for time here in a second. But previously you factored this here. And when they say previously, they mean in Algebra 1. It's been a while since y'all done factoring. Polynomials of the form ax squared plus bx plus c, where a is equal to 1. To factor polynomials of this form where a is different than 1, we first look for greatest common factor, and then we do our other steps from there. Can we look at this here? 5x squared plus 15x plus 10. When we factor this, there are different ways to do this, but all of them do agree on the fact that the first thing we should be looking for is a greatest common factor. Greatest common factor, we're looking for a number or variable or both, a number and variable that are in common with every single term. And if we look at this here, 5x squared plus 15x plus 10, so the greatest common factor between all three terms is 5. And we can factor that out. So we'll put a 5 out front. Now when we factor something out, essentially what we're doing is we're dividing each term by that number or variable. So if we divide 5x squared by 5, we just have x squared plus 3x. Because 15x divided by 5 would be 3x. Yes, and 10 would be 2. So we get 5 times x squared plus 3x plus 2. Now at this point here is where most of them diverge, because we can do the x method or we can do a square. We can set it up as squares to try to figure this out. But out of all of them, there is a set method that I like to use that I think is helpful and makes this process be a little bit easier. Because we've done our first step, greatest common factor. Our second step is to write two sets of parentheses with three spaces. So we'll still have our greatest common factor, but our second step is to write two sets of parentheses with three spaces. Now the three spaces, especially once you get used to these, aren't necessary. You won't have to put those in once you get the hang of this. I put the three spaces, especially as we start this, to make sure that the parentheses are big enough for everything to fit. Because if we look back at what we started out with, this here, when we distributed and got our 4x squared minus 17x plus 15, kind of where we're at, when we went backwards, each one of these had what? 1, 2, 3 things in it, yes? And 2 terms and a sign. That's what our 3 spaces are for, our 2 terms and our sign in the middle. Questions on how we got to this point here? Now the third step is to find the sign. Most other methods, some other methods will find the factors next, but I like finding the sign because this will make things a little bit easier in the long run. There's 2 parts to it, finding the sign. The first one is, and both of these is all based off the third term. If the third term is positive, the yes. All right, guys. So let's look back at this here. So the third step, find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. And this is really coming from the fact that, well, if we look back at this here, because when we multiply these two here in the second spots together, because -5 times -3 is positive 15, yes? The only way we can get a positive number with multiplication is if the signs are the same. Because if we multiply 2 positive numbers together, a positive times a positive is still a positive. A negative times a negative is a positive. They're the same. So when we factor, if this third term is positive, it's telling us the signs have to be the same. They're either both going to be positive or both going to be negative. Now, the reason we have it matching the middle term is because when we multiplied negative 5 and negative 3 together, we got positive 15. But the middle term was our addition of these other two, our negative 12x minus 5x, which did indeed give us negative 17. Because that middle term will tell us what the signs are when the third term is positive. So since here the third term is positive, the signs are the same and they match the sign of the middle term, which tells us both signs are positive. Now that does beg the question, what if the third term is negative? If the third term is negative, then signs are opposite. If the third term is negative, the signs are opposite, which means one is positive, one is negative. And in that case, you're just going to pick. Is the first one positive or negative? And whichever one you don't pick goes in the other spot. Questions on this so far? All right, that leads us to step number 4. Find the factors of the first and third term. For the first and last term. Find the factors of the first and third terms. So when we look at this here, our first term is x squared, and our third term is 2. So if we listed these out, x squared, factors, what multiplies together to give us x squared? X and x, because that's the only thing, two things that multiply to give us x squared that will actually work. We don't ever consider 1 and x squared, it actually wouldn't help. If 1 and x squared was a possible factor or set of factors, that means they're still a greatest common factor. So 1 and x squared only works really if x, well, there's a greatest common factor. Because there are reasons it doesn't work, and if we have time, I will look in and kind of show you that. Now, well, we only have x and x. There is no front number in front of x squared besides 1, which really doesn't help us in any way, shape, or form. These are the only factors, and if they're the only factors, go and plug them in. If there's only one set of factors, especially for x squared, there's only one, we plug them in. Let's look at the factors of 2. Times 1 times 2. Are there any other factors for 2? No. So we can plug them in. I could do 2 first and 1 second, or I could do 1 first and 2 second. It does not matter. Because at this point, we're plugging them in. Because, well, give me a little more room. There is one last step. And the last step is to check. Last step is to check. And what we're checking is to make sure that our x squared plus 3x plus 2 does indeed factor to x plus 2 times x plus 1. Now, most of the time when we check this here, and a lot of different places would say we're going to multiply the whole thing through. We won't multiply the 5, but we are going to do everything else. So the first thing it would tell us to do is to do x times x, which is x squared. Well, where did we get x and x from? So logically, shouldn't it multiply back together to be x squared? And the other one that they say we should do is 2 times 1. Well, where do we get 2 and 1? 2. So logically, those should multiply back together to be 2. The only one that actually changes, depending on the setup, is the middle term. Because we got the first term from our factors of the first 2 spots. Or the first 2 spots from the first term, yes? So they should go back together to be x squared. We got the numbers for the second spots or third spots in both from our third term, yes? The only one that changes, especially when we get into more of these, is the middle term, which is our x times 1 and our 2 times x. Well, x times 1 is x. 2 times x is plus 2x. And x plus 2x is that the middle term we wanted? So, these are the correct factors. Because if we wanted to, we could multiply all the way through. There's nothing wrong with that. X times x would indeed give us x squared. X times 1 would be plus x. 2 times x is plus 2x. And 2 times 1 is plus 2. Which does line back up with what we have here. We're not going all the way back to the top here. Because that factor of 5, we didn't put it in, but we could and show that it does go all the way back to the top. But our 5 times x plus 2 times x plus 1 is this quadratic completely factored. Do be careful, especially when you do factor out a greatest common factor, to make sure it is included in your final answer. Because when we're just factoring, we do need that is part of the answer. Questions on this here so far? Luckily, the next one will be a little bit faster than the previous one because I am not having to write all the steps out. Now, when we look at this next one here, the first step, especially with factoring, is determining if there is a greatest common factor. So 4 will divide into all 3. Now we know a variable is not going to be divisible or a greatest common factor in all 3 because the third term is 60. It doesn't have an x. It doesn't have a variable, so there's not one in common in all 3. Now when we divide each of these by 4, 4x squared divided by 4 is x squared. 32 divided by 4 is 8, and we still have our x, plus 60 divided by 4 is 15. So our first step was find a greatest common factor. Our second step, especially if these factor, is to write our 2 sets of parentheses with 3 spaces. And again, our 3 spaces, this is just to help us space them out so that we have enough room for everything to fit. Once you do get used to these, you don't necessarily have to write the 3 spaces, because if you know have them spaced out nicely, you don't need it. So it takes care of steps 1 and 2. Step 3, if the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here the third term is positive, so the signs are the same and match the sign of the middle term, which is also positive. So our signs are positive and positive. And it might seem weird, especially with this here, or as I said earlier, with it being negative, we just have positive, negative. The signs are opposite. And again, when we plug this in, I'm not too concerned about what goes where because of step 5. Step 5 is to check. Right over here. And if something doesn't work out or something needs to be changed, step number 5 will take care of it. It will notify that something's in the wrong spot. We need to adjust. Now, that takes care of steps 1, 2, 3. Now we're on to step 4. We want to find the factors of the first and third term. Right, so we're looking at factors of x squared, yes? How many sets of factors of x squared do we have? 1, we just have x and. For all of our quadratics, wherever that variable is, it's just going to be x and x, t and t, w and w. It being squared, there's only one set of factors. There's only one way we can multiply the two together. And whenever there's only one, I just plug it in. I put it wherever it's at. Since it's in the first spot, they're going to go in the first. And there's not a number in front of it other than 1, so we don't have to include it. Factors of 15. Well, we have 1 and 3 and 5. With the factors of either term, I always start with 1 and the number itself, and then go from there. So 1 and 15, then we would try 2. 2 is not a factor of 15. 3 and 5 are. 4 is not a factor of 15 because it would be 4 and 3 point a number. I think it's 3.75. But we're done because the two factors approached each other, reached each other, and kind of passed each other up. Because the one after that would be 5 and 3. We already have it listed. We don't need it twice. Questions on how we got the factors of 15? Now, we need to plug them in. I didn't really put that, but we do need to plug them in. Then we'll pick a factor of 15 that we want to try first. 3 and 5. Which one do we want to put first? 5 second. It doesn't really matter which one we pick. We just got to pick one of them and put it first, the other second. So we have the factors of the first term plugged in. We have the factors of the third term plugged in, which takes care of step 4, which brings us to step 5, which is to check it. Well, we need to check and make sure. And the reason I say we just plug them in is because of step 5. Because step 5 is to check and make sure they are the correct factors. Because if we look at this here, well, as we said earlier, x times x is still x squared, because that's where we got the factors from. Our 3 times 5 is still positive 15, yes? First and third terms, they're still the same. Now we're looking at the middle term, which is going to be this here. X times 5 is positive 5x. 3 times x is positive plus 3x. And 5x plus 3x is positive 8x. Is that the middle term we wanted? Well, yes, because we wanted plus 8x, positive 8x. We have positive 8x, so it works, yes? Now, I'm going to erase the 3 and 5 for a second. Do not erase the 3 and 5 on your paper, because the other factors that we have were 1 and 15, yes? Now, if we check this here, well, x times x is still x squared, yes? 1 times 15 is still 15, yes? I changed the second numbers, but the first and third terms still give us x squared and 15, yes? They did not change. So let's look at the middle term. X times 15 is 15x, positive 15x. 1 times x is positive x. And 15x plus x is 16x. Is positive 16x the middle term we want? No. It's a completely different term. So as we see here, by changing what the factors of the third term was that we put in, we got a new middle term. Greatest common factor if there is one, and then we work down from there. Now, that's why step 5 is so important. Yes and no. Yes, it's a great way to verify and know that it is. No, in that, unfortunately, the only way to know that it is without doing step 5 is if you've done enough of these. You get the ability to kind of see what they are. And out of most of what we'll do in Algebra 2, these here are really fall back to guess and check. We're going to guess. We're going to put something that we think is going to be it, check to make sure, and then we can move on from there. Does that make sense? It's the only downside to factoring is that it does take a little bit, but once you get in the hang of it and start seeing how the factors work together, you'll be able to piece them together a little bit quicker, a little bit easier. Does that make sense? And for factoring, I would highly encourage using a pencil because there is going to be some changing the numbers here and there. Let's look at this one here. I think we're going to be running out of time. Now, when we look at this next one here, the first thing we always look for is a greatest common factor. Is there a number that will go into 4x squared, 13x, and 3? 1. 1's the only one, and unfortunately, it doesn't help us. So there's not a greatest common factor between all 3 terms. So we go to step number 2, which is our 2 sets of parentheses with 3 spaces. Find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. So it's positive, so the signs are the same and match the sign of the middle term, which is also positive. So our signs are plus and plus. So if the third term was positive, the signs are the same and match the sign of the middle term. Negative and negative, yes. Because no matter what it is, if the third term's positive, the signs are the same and match whatever the sign of the middle term is. Now, that leads us to step number 4. Factors of the first and third term. Yes? 4x squared. Well, as we've seen so far, x squared, what is its only factors? X and x. Not quite. Now, 4x squared, if we look at it as a whole, well, we can say that we have 1x times 4x. The other factors of 4 are 2 and 2, which would be 2x and 2x, yes? But in either factor, both terms have what with them? Just an x, 1x, yes? So no matter what factors I pick, I know that it has to have an x with it, yes? So if I know that it has to have it, might as well put it down. Does that make sense? It's not so much that we're ignoring the 4. I just know x squared has to be x and x, no matter how we set it up, no matter how we do it. So might as well put it in. If there's only one set of factors, there's only one way that it factors. Might as well throw it in, and then we'll worry about the rest of it in a second. And the same thing is true with 3. What's the factors of 3? 1 and 3, yes? Are there any others? No. That's why we call 3 prime. It's a prime number. There's only one set of factors. So I'm just going to throw them in. I could have put the 3 first and the 1 second, or as I put here, I put the 1 first and the 3 second. I just need to set it up in a way that I can check it and then go from there. Now, the only other factors we have not put in are the factors of 4, yes? So I'll let y'all pick. Do we want to use 1 and 4, or 2 and 2. 2 and 2. 2 and 2. Now, that brings us to step number 5, which is to check it. And I'm going to point this out one more time. If we did 2x times 2x, well, the x times x is x squared, yes? 2 times 2 is still 4, yes? Is that the first term? Yeah. So that still gives us our 4x squared. Our 1 times 3 still gives us our plus 3. Now, if we check the middle term, 2x times 3 is positive 6x. 1 times 2x is plus 2x, which gives us positive 8x. Is that the middle term we want? Now, we could jump straight to 1 and 4, or we could flip the 1 and 3. If I switch the spot of 1 and 3, will it change anything? No, because if we switch 1 and 3, I'll go on and show it. Well, I'm doing 2x times 1 and then 3 times 2x. Even though it looks different, it's the exact same thing, yes? So, instead of doing 2x and 2x, we can do 1x and 4x. So the question is, where do we want to put the 4? We're on the second spot. I'm just picking one of them. We're just picking one of those two to put it. Because once we put it there, we will check it again. X times 1x is x. 3x times 4x, well, 3 times 4 is plus, we still have our x, 12x. X plus 12x is 13x. Questions on this here? Questions on any of this so far? And again, I'm going to emphasize this a lot, especially when we're going through 3-1. Just because you don't see these on the first time, you do not get them set up on the first time, plugging them in, there's nothing wrong with that. Sometimes it's going to take 2, 3, 4 times setting them up, trying different arrangements to get the correct factors. And luckily, I'm not going to throw them in, especially for this first section. Not everything factors. Not everything has a factor, or a set of factors that work, or are real factors. So the only unfortunate thing with factoring is it doesn't always work. We will go through several different methods of solving quadratics. There's really 5 main types. 3 of them will not work every single time. 2 will. And the 2 that will work are going to be the last 2 that we actually go over. We save them for the end. Unfortunately, this is where we're going to stop for today.